The moment you split into services, a new failure mode appears. One team changes their API, a field gets renamed, and another team's service breaks in production because nobody's local tests ever ran both together. The obvious fix is end-to-end tests that spin up everything at once. They're slow, they're flaky, and they need a whole environment. Contract testing gives you the same safety as a fast unit test on each side. The consumer writes down what it needs. The provider proves it still delivers it. Let's pin a contract. Here's the shape, and the name says it, consumer-driven. First, the consumer, the service making the call, writes a unit test against a mock of its provider. In that test, it sets out exactly what it sends and exactly what it expects back, and packed records that into a contract file. Second, that pact is handed to the provider, who replays every interaction in it against the real service and proves it still satisfies them all. And third, the magic. If the provider makes a breaking change, renames a field the consumer relies on, it's the provider's own test that goes red on the provider's machine before they deploy. The break is caught at the source, not discovered downstream in production. This is the consumer side. Our daily digest service reads Todos to build a summary email, so it depends on the Todos API. With PactNet, a third-party library, we declare an interaction. Upon receiving a GET for to-do 42, given that to-do exists and is active, respond 200 with this exact body shape, an ID, a title, and a status. Then we run our real client against Pact's mock server and assert what we actually care about, that the status comes back as active. When this passes, Pact writes out a contract file, the consumer's recorded expectations, that we hand to the Todos team. Notice we never started the real Todos service. This is a fast, local unit test. And here's what that test produces. The Pact itself, a plain JSON file. It names the consumer and the provider and lists every interaction. The provider state that has to be set up, the exact request, and the exact response the consumer is counting on. This file is the shared source of truth between the two teams. It's not documentation that drifts. It's an executable contract generated from a real test that the provider is about to be held to. Check it into a Pact broker, and both sides can see exactly what's promised. Now flip to the provider. The Todos team takes that contract and runs the verifier against their real service, booting it with Web Application Factory, the same way we did for integration tests. Pact sets up each provider state, replays every request from the contract, and checks the responses match what the consumer expects. Here's the payoff. The day someone on the Todos team renames status to state, this verification fails on their machine, in their CI pipeline, and they find out they're about to break the daily digest before they ever merge, let alone deploy. The contract turns a future production incident into a red test today. Two more pieces to make this real. First, a Pact broker, a shared service that stores the contracts and the verification results, so each team can see which versions are compatible with which. And on top of it, can I deploy? A check you run in your pipeline that answers, before you ship, will this provider version still satisfy every consumer that's live in production? If any contract would break, the deploy is blocked. And the scope? Reach for contract testing at the seams between services, a gateway, and the services behind it, one microservice calling another. Inside a single service, the in-process integration tests from episode 8 already have you covered. Contract tests are for the boundaries you can't test in one process. So that's consumer-driven contract testing. The consumer records exactly what it needs as a pact. The provider proves it still delivers it. And a breaking change becomes a red test on the source team's machine instead of an incident downstream. Pair it with a broker and can I deploy, and teams can move independently without a slow, shared end-to-end environment. Next time, we extend the Trellis guardrail idea to your own codebase, writing and testing a custom analyzer that enforces your team's rules. Subscribe, and I'll see you there.